We are talking now about robot types and different types of robot technologies. Okay, so here we go. Questions to look out for in this one. What are actually some different types of robots we're going to talk about in this video today? What is the difference between open and closed loop systems? And what types of robots do we actually use in our robot courses that we teach here at St. Clair? So there's two main types of control systems you're going to come across for robots. Basically non-servo and servo systems. The earliest type of robot that people created was a non-servo, which is considered a non-intelligent type of robot. The second classification of these is the servo type. So what do we mean by that? Let's first talk about different types of links and joints. A prismatic joint, that's what we're looking at over here. Prismatic or linear joint, that is basically like a pneumatic cylinder, so something that moves in a linear motion. So basically one thing sliding on another. A revolute or a rotary joint, that is the second picture here. That is like the joints, most of the joints in your human body, so like your elbow. So basically fixed axis, something rotates around that fixed axis, that would be a rotary or a revolute joint. Two different types of joints we're talking about. So open versus closed loop systems. Let's take the example of your clothes dryer. So electric clothes dryer. You can get these in two different models. Older style or cheaper style, this would be an open loop system. So basically you put your clothes in the dryer, you turn it on, you set a timer, and it's going to basically run for as long as that timer goes for. So it's not checking to see whether your clothes are dry or not. It's basically, you tell it to go, it's going to run for 45 minutes, regardless of whether your clothes are still wet or whether they're catching on fire. Either way, it's going to run for 45 minutes. It's not checking with the outside world for anything else. Everything is just based on time. So that is basically an open loop system. No sensing of the outside world. That is open loop. Okay, we call that a non-feedback style system. So non-servo robots were like this as well. So these would basically be simplest type of robot, like a pick and place or a fixed stop robot. So basically, like we said before, a robot could be anything that is programmable, at least 3-axis, has a multifunction manipulator, but maybe not a whole lot of adjustment or intelligence to it. So if you just tell something to move and it moves in a certain direction and then it stops but doesn't really sense the outside world, that could be a non-servo type of robot. So no feedback mechanism there. So for example, if we have our controller over here, we tell this robot to go. For example, if this is a pneumatic cylinder with a gripper on the end, we basically say move over there until we hit a limit switch and then stop, or you just move until we hit something and then grab and then come back. That's a very simple non-servo style robot, and that is basically what this diagram is showing right here. That is basically very old school style. We don't use this a whole lot anymore, but a simple pneumatic controlled gripper style robot would be what this is. Characteristics of these: relatively inexpensive, simple to understand and operate, pretty precise and reliable because we're just going to a fixed position each time, very easy to maintain, very small in size, but very limited as to what you can do with them as well. So let's talk now about a closed loop system. So a closed loop system, if we want to go back to this clothes dryer example, let's talk about a clothes dryer that actually senses dampness. So you put your clothes in the dryer, tell it to dry, and it basically has a sensor in there that detects moisture. So every 10 seconds or so, it's going to get a reading of how damp your clothes still are, and then adjust whether it still needs to keep on running or not, because it's going to go until it decides that your clothes are actually dry. Okay, so it has a limit where it says, once the dampness hits a certain level, clothes are dry, I'm now going to shut off. That is a closed loop system, so it's actually sensing the outside world and determining whether it needs to keep going or not. So that is a closed loop system. So we call that a system that actually has feedback embedded into it, is looking at its error and determining whether it needs to keep moving or not. So we could do this same thing with a robot system as well. So basically I'm going to try to move, I'm going to measure how far I moved, and determine if I'm at my desired point or not. So if I want to move 100 millimeters in one direction, I'm going to move. I'm going to keep on measuring how far I went. Once I get close to that point, I'm going to stop. Okay, so that would be a closed loop system, or a servo-controlled robot, as we would call it. There's a diagram here. Similar like we had before, controller sends out a signal. Now we've got a couple of new devices in here. We actually have something like a resolver that measures how far we've moved. So that measures rotary position to determine how far we moved. We have a tachometer. That is not a tachometer. That is a tachometer. That measures how fast we're going as well. And we can use these things to calculate how far we moved, how fast we moved, and control our position very accurately. Okay, so this would be a servo style of robot. Now there's three major types of drive systems you're going to see in industrial robots. This is going to be hydraulic, pneumatic, and electric. Hydraulic, this is basically the very earliest form of robot actuation. Basically, high pressure oil is used to move things with fluid power. Can handle very high loads with hydraulics. Self-lubricating, smooth operation at low speed. Disadvantage of these things, very messy to use. You need return lines, and they take up a lot of space because you need that big hydraulic unit in order to run them. Pneumatic systems. This is basically using compressed air to make things move. Things we like about pneumatic system, very inexpensive to use. Don't pollute the area because there's no mess involved. You're just basically venting air out into the atmosphere. Can be used in explosive environments. Disadvantage of these, you need a clean, dry air source for them. Noise pollution from the exhaust, leakage of air can be a concern, things like that. Okay, and then the third one, the robot drive system, is the electric drive system. This is where everything has gone in modern robotics today, going to electrical drive systems. Typically what we're using now started off with some stepper motors, and then DC servos became popular. AC servos are now basically the way that everything is done now. So AC servo motors using encoders for feedback. The advantage of these, very good positioning and accuracy, not very much maintenance, very good reliability. Disadvantages, they actually take some sophisticated control systems, but that is what you're learning in this program, is basically how to control these things. And you need to be mindful of the environment. You need to protect it from high temperature, wet, dusty, or explosive environments, things like that. But basically, what we do now with robot systems, we have what we call direct drive motors. So we are putting our motors directly on these joints. So typically, like we talked before about all these rotary joints that we have, or resolute joints. So we're putting a motor directly connected to the joint. So we have a motor, goes right here on the joint, and can directly make things move very quick, very accurate, like that, with great results. So here's some pictures here, and you can see wherever we have, that's a motor there, and you can see how these motors are located like that, directly over the axis when they're running. So let's talk about some different types of robot manipulators that you're going to actually see. The most common one that you'll see, and what we have in our lab out here, is the articulated robot, which looks like this. This is probably what you're most familiar with talking about industrial robots. So this is what we call a 6-axis articulated robot. Axis meaning how many joints it has. So if you want to talk about your arm has a shoulder, an elbow, a wrist, a bunch of fingers. If you want to count how many axes that has, 1, 2, 3, 4, 5, 6. That is 6 actual axis there if you want to consider how you can move like that. So that's basically what this robot is. So we call this a 6-axis articulated robot. That is what we are using in our labs. The big orange ABBs and the little white ABBs, which you'll be using in your next course. Cartesian robot, we'd also call this a gantry. This moves along the XYZ planes. It can go basically back and forth, forward and back, and then up and down. So remember, 3 axis or more makes it a robot. Cylindrical robots, I've never seen one of these in action before, but this basically spins around in a circle, kind of as a pick and place operation like that. A polar robot, very similar to the cylindrical. The SCARA robot, you'll see these a lot in electronics, pharmaceutical, things like that. Extremely fast motion, but only basically going up and down and picking and placing like that. But they move, you'll see some videos of how these things move, but they can go very, very fast. And then the Delta or the spider robot, they have 3 arms that move from up above, and you'll see some videos of how these things move as well, used a lot in the packaging industry. That is the Delta robot. Okay, so we will watch some videos now from a robot trade show and see how these things get used. All right.